Okay, we shall continue. Yeah.
Pressure reducing.
Am I audible?
Yes, sir.
Yes,
Okay.
sir.
Professor Srinidhi Kulkarni wants to add a few things with regards to the introductory part. Then we will take up the next part. Okay. After he finishes, we will watch a video and then continue with the next part. Okay. Just a minute. Give me a minute. Yes.
Yeah, am I audible now? Someone respond?
Yes, sir.
Yes, sir.
Okay. Now I received a call, so I was standing outside. By that time, I think some of you have asked a doubt regarding pressure reducing valve and pressure relief valve, right? So I just want to add up to that thing and explain you. Welcome to lunch. And explain you what is that pressure reducing and pressure relief valve, right? So let's take a very crude example, and then we'll go for an example of pressure cooker. Okay. Suppose some system is designed to run at a maximum pressure of 100 bar. So you cannot exceed that 100 bar pressure. So to be on a safer side, you keep your pressure reducing valve setting at 90 bar. Okay. And pressure relief valve setting at 100 bar. Now let's see how does this work. In any normal situation, let's say that the pressure in the system is around 60 to 70 bar every time. Right, and the load in the system varies like maybe 1 ton to 1.5 ton. So when the load is around 1 to 1.5 ton, the pressure is somewhere around 60 to 70 bar each and every time. But sometimes due to mishandling or improper loading something, the pressure may slightly increase from 70 bar and may go up to 85 or 90 or 91 or 92 bar, right? Instead of putting just 1.5 load, maybe 100 kg or 50 kg or 200 kg extra load might have been put on the cylinder, let's say a cylinder. So the pressure will rise from maybe around 70 bar to 85, 88, 90, 91, 92. As this goes on increasing, the pressure reducing valve will come into picture. What does that pressure reducing valve will do is, some oil that is flowing into the system, okay, because of this increased pressure, that pressurized oil is taken out slightly from the system and sent back to the tank. When some of this pressurized oil is taken away from the system and sent back to the tank, obviously because of reduced volume and reduced pressure, the pressure will drop again from 91 to 92 bar, maybe to around 75 or 80 bar. And this continuously goes on monitoring. Whenever the pressure slightly increases from around 60, 70 or 80 bar and goes up to 90, touches 90 or even comes close to 90, that part is slightly released by taking out some of the pressurized oil and it is maintained back in the system. This is pressure reducing valve. But sometimes what happens, due to total ignorance or something, instead of just putting 1 ton or 1.5 ton, someone may drop suddenly 3 ton load on it. Accidentally, things might happen, no one knows, right? Sometimes total ignorance or there is some improper functioning of a system or loading material handling system and all. Instead of 1 or 1.5 ton, 3 load ton drops on the system. Then what? Pressure will spike. Instead of going to 80 or 90 bar, it may go to 120 bar or 130 bar. Then what? Pressure reducing valve will not help. Pressure relief valve will come into picture. What this pressure relief valve will do is, it will give a bypass to that whole system where that pressurized oil is existing in the system. It will give us such a bypass so that maximum oil from that system is sent back to the tank. When maximum oil is sent back to the tank, totally pressure reduces from maybe 120, 130 bar and again it comes back to 60 or 70 bar. That is pressure relief valve. This was a very crude example in terms of numbers to make you understand how each functions. Now let's go to pressure cooker example. Sir, a cooker lid.
That's bigger. Just give me a minute.
Now, if you observe pressure cooker at your home, what do? If you want to cook rice, okay, there's a general rule, right? If you want to cook rice, you need to pour some water at the bottom of the cooker. And then in some utensil, you're going to put raw rice and again water in that utensil and close the lid and put the whistle on and turn on the flame, right? Now what happens? As the water starts boiling, it gets converted into steam, thereby cooking the rice, raw rice into the cooked rice. As this flame is turned on, as the steam goes on increasing, the pressure goes on increasing. When it reaches certain limit, the whistle blows. Right? Cooker की सीटी बज जाती है. That means what? When the blowing of the whistle means what? The pressure inside the pressure cooker has reached a certain limit. So the whistle blows and takes out some pressure, takes out some steam out of that pressure cooker, thereby reducing the system pressure and bringing back to normal. Then again you wait for another whistle blow. And again you wait for another whistle blow, depending on how much time you're planning for cooking. Right? This is normal case. So this is your pressure reducing valve, blowing of the whistle. But if you observe the pressure cooker lid, just besides that whistle, there's a small hexagonal type cylinder given over there, which is the safety valve. Sometimes, not sometimes, many times in many houses, what happens in the work pressure or due to ignorance, instead of pouring water, correct quantity of water in the pressure cooker, like maybe 2 or 3 glasses of water are required, someone may pour only half glass, or they may forget to pour water in the bottom of the pressure cooker. They directly take the cooker, place the utensil, pour water in the utensil, but not in the cooker, and directly switch on the flame. In such case, because in absence of water or very little quantity of water, the steam that is produced is totally dry steam. If it's totally dry steam, the pressure increase is huge. I mean, the increase in the pressure is very huge or sudden with high temperature. In such cases, blowing of the whistle will not work. So what happens? Just besides that whistle, there is a safety valve given. That safety valve is ejected out. It totally blows off. When it totally blows off, you can see that there is a hole created in the lid. Big hole. Through this hole, entire steam that is there inside the cooker escapes out. You can see the jet of the steam coming out. This is pressure relief valve. Because the system pressure has jumped or spiked suddenly beyond the limit, the safety valve got operated and all the steam escaped, or all the hot gases escaped. This is your relief valve. But just blowing of the whistle is reducing valve. It doesn't takes out all the pressure. It only takes certain amount of pressure out of the system to maintain it below certain level. That's your pressure reducing valve, whistle. And the safety valve that is put on the cooker lid, okay, that's your safety valve or relief valve. I hope this is okay. Harshit sir will continue now. Thank you.
Okay, so let us watch a video for this, what we have understood till now regarding the pressure relief valve. So are you, one second, I will share the screen. Give me a moment. Are you able to see this? Please confirm. Hello.
Yes, sir.
Okay, so I'll on the video.
Welcome to Lunchbox Sessions, bite-sized industrial training. Hello, this is Carl at lunchboxsessions.com. In this video, we're going to look at basic functions of a very important pressure valve called a relief valve. Many hydraulic systems use a pressure relief valve as the primary means to limit maximum system pressure. Without a relief valve in place, pressures could potentially build to an excessive level where the machine might be damaged or perhaps a hose might burst, endangering human lives. The type of relief valve we will be examining is the simplest style with only one poppet and one spring. It is known as the direct acting relief valve. This live schematic shows a fixed displacement pump sending a flow of 10 gallons per minute through the system. Our directional control valve will remain energized in the cylinder extend position. The relief valve is shown in cutaway form so that we can see all of the details and actions of the relief valve as it responds. The system pressure is indicating 200 psi, which is calculated by looking at the mass being lifted, 2,000 pounds, divided by the 10 square inch surface area on the bottom of the piston. The controls show that the relief valve is set to 300 psi. But how do we know this? The only true way to know the relief setting pressure is to observe the system in action and the values on the system pressure gauge. Let's add a 2,000 pound brick for 4,000 pounds total divided by 10 square inches, and we did not achieve 400 psi. The cylinder crashed back down to the bottom, and the maximum pressure on the system gauge indicates 300 psi. When flow from the pump can take no other path than through the relief valve, the pressure value on the system gauge then indicates the true setting of the relief valve. Let's add 3 more bricks for a total of 10,010 pounds. We would need to trap a system pressure of 1,001 psi to lift this load. Now, if we tension the spring on the relief valve, we notice that the system pressure is climbing as the relief valve poppet pushes against the flow. As the relief valve can only be adjusted up to 1,000 psi, we are unable to lift the load on the cylinder. We simply cannot trap the required pressure in the system. Watch what happens as we remove 1 brick for an 8,000 pound remaining load divided by 10 square inches for 800 psi system pressure. The cylinder starts to lift, but notice that the relief valve is not closed. Let's once again add a brick and remove a brick while watching the poppet in the relief valve. Removing a brick allowed the poppet to advance upward, but the relief valve does not quite close. Removing 1 more brick for 600 psi system pressure, we see that the relief valve has closed completely and that the cylinder has increased speed. Again, let's add the 4th brick and remove it while watching the relief valve and the cylinder. Remember that the relief valve is set to 1,000 psi, but clearly the valve opens at 800 psi and begins to direct at least some of the system flow back to tank. In this case, the cracking pressure is 800 psi, where the relief valve setting is actually 1,000 psi. The difference between the cracking pressure and the setting pressure for this particular relief valve is 200 psi. In order to lift the system at maximum possible speed with an 800 pound load, the relief valve would have to be set a little higher than 1,000 psi. In future videos, we will examine pressure override in more detail and look at more complex relief valve designs.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.
Yes, I hope you understood with regards to the system also.
Is set to
In this,
300 psi.
you can just observe when it gets activated and all. I hope this video finds you in good understanding of the entire process. Just give me a minute, I'll switch. Let me know if you are able to see the screen again, PPT. Yes?
No, sir, not yet.
Not yet? Okay, I think I need to switch. Give me a minute. Yes, I think now you are able to.
Yes, sir.
Okay.
Yes, sir. Now
One second. Yeah, give me a minute. Okay, so the next type of valve which we are supposed to see is the unloading valve. So this is the circuit diagram of an unloading valve. Now I will tell you one thing, that whatever we are learning in this chapter, for example, your flow control valve, pressure control valve, or directional control valve, all these operations will be perfect once we go to the next chapter, because the last chapter is the next chapter wherein you are going to understand all the types of operations in the circuit. What will be the role played by these valves in the circuit? For example, now you can see unloading valve circuit, wherein you have a typical hydraulic system with the tank, filter, pump. This is the check valve. This is the DCV, spring-centered, lever-operated 4x3 DCV. This is your actuator. Okay, it is for a typical double acting hydraulic cylinder. In this, if you see, what is the unloading part of this? What is unloading? Here you can see there is a pressure relief valve. Okay, and this is your pilot line. Okay, so I had explained to you few minutes back regarding that after extension the pump will unload to the tank. Now let us see how that operates. See, during this left envelope, when it is actuated, oil from the pump will enter this check valve, which is a non-return valve, and will pass from this connection over here, and oil will start entering the blank end of the cylinder, pushing the piston aside. What happens to the oil which is already present here? That will start returning back through this connection, which will be established here to the tank, correct? After the cylinder completely extends, still the pump will be on, means the oil will be flowing inside through this check valve. But now what has happened? If the oil tries to enter here at the blank end, this extension is completed. So there will be no space for the oil to enter here. So what will happen? Pressure will start generating here. To avoid that generation of pressure, what happens? Suddenly the oil will start flowing back here through this pilot line, okay, and it will push this lever. This is nothing but a lever or a connection that is not yet established. So since it pushes that lever over here, the connection is established, and suddenly the pump will start unloading to the tank. So instead of sending that oil through the check valve to this blank end of the cylinder, since already that work is over, it will pump will simply unload to the tank, and this kind of a pressure relief valve or pressure control valve is called as unloading valve. I hope you now understood. Okay, this is what is the significance of unloading valve. Okay, so I think we can stop today here, and we will take up the next one in the next class with this last one. Okay, so this is one of the sequence valves. Now here, what is sequence valve? As I had told you people, that sequence valve is a valve in which you people are going to complete one operation and then send it to the next operation. So here you can observe the oil enters, completes this actuation, okay, and then enters out and then enters the next operation and completes the sequence. To understand the sequence valve better, you people are supposed to see a video. I think in the next class we will take that, so that we can take up that video, and I think in the next class we will complete sequence valve as well as flow control valve. This chapter will be over in the next week. Okay, so I think we will stop here because we have still sufficient classes. We can cover it appropriately. Okay, I don't want to hurry. So today we studied, just to quickly brief and revise, we started with what is pressure control valve, and then we understood what are the functions of pressure control valve. Then we started with the types of pressure control valves. Followed by that, we studied one by one the pressure relief valve, then we studied the pressure reducing valve, then we studied unloading valve, the remaining two, sequence valve as well as this counterbalance valve and safety valve, we will take it up in the next class. Okay, I am just taking the attendance. So once again, so I feel this is enough for today. We can take up in the next class the remaining bits. Okay, so we can complete this chapter in the next class. Okay, I hope all have done your examinations well. First test. So start preparing for the second test. For the second test also, major portion will be from fluid power also. Okay, first test you didn't have anything. So in second test you will have major portion from fluid power as well as third test. Okay, fine. Any doubts? Any clarifications? Or shall we end? I will upload this video. Okay, don't worry.
Excuse me, sir.
Yeah.
Sir, what's the date of open book and second IA test, sir?
I think they have not yet decided because still the IAs of 5th sem and 3rd sem are pending. So next week we have IAs of 5th semester. After that we have IAs of 3rd semester. So somewhere they will plan. So I will let you all know definitely once they announce it. Okay, from their end. Okay,
Okay, sir. Thank you, sir.
fine. Okay, then I think we can end the class for today. Let us meet up in the next